Hello everyone, in today's video we're going to be looking at index laws. So there's four main rules you need to learn and they're really not that hard. The first rule is that if you have a base to the power of something times another base to the power of something, the same number, so for example 2 to the power of 3 times 2 to the power of 2, the indices are added together. So this is shown here, m plus n. Now, you can just remember this rule, and that is useful, but to make it easy for you, I've tried to do a form of a proof here. So, for example, if let m be 3 and n be 2, if we have a to the power of 3 here times a to the power of 2, what we're really doing is a times a times a times a times a times a, which is equal to a to the power of 5, or 3 plus 2. So that is the first rule. Now, the second law is similar, but it's just with subtraction. So a to the power of m divided by a to the power of n will be this equal to a to the power of m minus n. So again, it is good to just memorize that, but a little way I like to think of it to help you remember it is if you write out all of the a's, you can see that they cancel out, giving you a to the power of 1, or 3 minus 2. Now, another bit of pseudo maths for you to help you remember it is it's a bit like going down a level of, a function. So if you're multiplying the two numbers together, you are adding the indices. And then here we can see if you're taking it to the power of, you're actually timesing the indices together. So as I said, here we can see a to the power of m to the power of n is equal to a to the power of m times n. And again, you can see this, you can prove this by writing it all out. We can see a to the power of 3 to the power of 2 is the same as a times a times a to the power of 2. And if we spend a while writing it out, which I did, we have a times a times a times a times a times a, or a to the power of 6. And again, we can link back to the first rule here and see that we could also show this as a to the power of 3 times a to the power of 3. And we know, going down the power and also remembering this, a to the power of 3 times a to the power of 3 is equal to a to the power of 3 plus 3, or a to the power of 6, which we know is right. Now, this is the last little rule, and basically, if we have two numbers here to the power of something is equal to a to the power of n times c to the power of n. And again, just written this out here to show it to you clearly. Let's say n is equal to 2. That means that a to the power of n equals a times c times c. And we can see ac squared equals ac. Yeah, that's basically it. Index laws are really not that hard. Just make sure you remember these four main ones. I would suggest making a note of each of them and then giving each of these example questions a go. You can pause the video now to have a look at them if you want. I'll give you just 1 second. Okay, so let's start off with the first one. X squared times x to the power of 5. We know that we must add the indices together to give us x to the power of 7. 6x to the power of 5 divided by 3x to the power of 3. Now, we've introduced a constant here, but really don't worry about it, don't overcomplicate it. If you need to, just imagine writing it out as a fraction. And we know with BIDMAS, we don't need to worry too much about the order of which we're multiplying or dividing. So we just get 2 to the power of x, 2 times x squared, excuse me. So we can sort of just treat them as separate divisions. 3x squared to the power of 3 divided by x to the power of 4. Now it's important we remember this rule here. So we need to take 3 to the power of 3, not just the x squared. So that will give us 27x. And then for this one, remember, we're taking it to the power, so we need to multiply. So 27x to the power of 6 divided by x to the power of 4. again, you can look at it as fraction. 27 x to the power of 6 over x to the power of 4, which equals 27x squared. Okay. Now, these are some harder examples. At the GCSE level, if you're doing GCSE further maths, it's not going to get... I mean, it gets worse than this, but we'll cover that in future videos. For normal GCSE maths, this is as hard as it really gets. 10x squared plus 6x minus 10x. I always like to make a super obvious note of this negative here, because it's very easy to overlook it and end up saying that this is plus 15 when it's actually minus 15. Collect the like terms. 10x squared minus 4x minus 15. And then expand this. And then let's say, just practice, you could try and simplify that, but we've already done that. Final one. What we have to do is we factorize out the treat it as separate fractions. I was just thinking about factoring out 5. I'll try that in a second to see where it leads us. 4x, again, we take here to the power of 5, plus 3x, 3 take 2. Boom, that's the question. I mean, you could factorize out the 5 to give you 4x to the power of 7 plus 3x to the power of 3. But it's just a bit of a slower way. But yeah, thank you very much. Hope you guys enjoyed the video. I'll see you next time.